Okay, so this video is going to cover the first part of section 4.7. It's about flowchart proofs. So hopefully you watched the video last week, and this will just be kind of a continuation of this, especially for those of you that weren't able to be in class this week. So starting off with here, we're going to do this warm up in class. So I would encourage you to pause the video and try this on your own. We're writing a proof. So remember, a proof means we're explaining why with our statements and reasons for each statement. So they tell you, your given here is that PR and QS bisect each other at T, and we're supposed to prove that the triangles are congruent. So pause this and try that out first. Okay, so hopefully you get a chance to try that out. So what we want to do here is, remember, in a proof, we're always justifying every statement. So the big thing would be we'd start off with things that are given. So example, PR and QS bisect each other. And yes, you have to write it down, even though it is written right up there. And that's given. And so a good thing to say would be, okay, if I see that word bisect, does that word mean anything to me? So bisect means that they cut each other in half. And so because of that, we know that these two are congruent to each other and these two are congruent to each other. That's what bisecting each other means. So our next step could be that PT is congruent to TR and QT is congruent to TS. And the reason for both of those would be the definition of bisect. Be good to have the little line symbols above there. And so we're just saying we know what the word bisect means. It means that they create these equal sections. So there we've got a couple of pairs of sides, and we've used our given. So at this point now, when you think about some other conjectures, some other things that we might know in this picture, and all based on the conjectures, we're only allowed to use for our reasons the givens, so our facts that they were given, any definitions of words,
should now be back in our class.
Conjectures that we've already talked about, and math. We're not going to have a whole lot of math involved anymore, but those are kind of the big three: is givens, definitions, and conjectures. So the other thing that we'd have in here would be some vertical angles. So if you take a look at these two angles here, they are vertical angles, and we know that those two are congruent. And so that would be angle PTQ and STQ. And so we'll say we know those are congruent, and that is the vertical angles conjecture. Okay, so that gives us our three things. We've got these two pairs of sides, we've got the angle in the middle, so now we can use our SAS conjecture to explain why the triangles are congruent. Now, I did mix up these letters here. If we're going to go with PQT, it's got to be RST. So that's one change we got to make. So PQT is congruent to RST. Oops. Undo. PQT is congruent to triangle RST by SAS. Now, in this case, they didn't ask us to go any further. We just had to stop when we proved the two triangles are congruent, so we are done. Here we had our given, our three statements that said the pieces were congruent, and then our triangles being congruent. So today, the new thing is not going to be any new conjectures. It's not going to be any new big ideas. It's going to be how we organize our proofs. So today we're going to talk about how to organize our proofs as a flowchart, because a flowchart is going to allow us to clearly demonstrate our understanding of the proof. It's going to show the logic as actual arrows. So if any of you have never seen a flowchart before, this is kind of what a flowchart is. It's where you start at the place here, and this is how to play Pictionary. So you draw a picture. You say, okay, did they guess it? No. Okay, so you point repeatedly at the picture. Did they guess it? No. Keep pointing at the picture. And if you've ever played Pictionary where the person just points at the picture and says, but anyway, it's supposed to be a joke. Not really that funny, but whatever. So in a flowchart proof, we're always going to place each statement in a little box or bubble, and then the logical reason gets written underneath of it. So for example, here, if we were using the statement that RC is congruent to RC because it's the same segment, which is something that we've seen a lot in these proofs, it would look like this. The statement gets written in the box, the reason gets written right below it, and that's it. The big difference then is the logical flow of our proof is going to be shown with arrows between them. This kind of idea of a cause and effect, basically. If one fact leads us to another fact, it has an arrow going from one to the other. So here we've got the exact same proof that we just did, along with the exact same steps. So we've got PT is congruent to RT, definition of bisects. QT is congruent to ST, definition of bisects. We've got our given, we've got our vertical angles, and we've got our triangle conjecture. What we have to do with a flowchart proof is organize this thing. And you can kind of do this kind of top to bottom, left to right, however you feel like doing it. A lot of the ones in the book are arranged left to right just because that takes up the least amount of space, but that really doesn't matter. Big thing you want to keep in mind here is the arrows tell you what's going on. So we have to start off with things like the given. In this case, this given has to come first. The only reason we know that is because it was told to us. It doesn't need any arrows coming into it. But what we do need is arrows going out of it. And so these two things, the fact that these two pieces of segments are congruent, came from the fact that these bisected each other. And so that's how we know that we need to add arrows on those. This thing directly told us this thing. It also directly told us that thing. And so we have arrows there. Now this one here, these angles being congruent, was the vertical angles conjecture. In this case, nothing else told us that. We knew that just because they are vertical angles. And so again, that one doesn't need an arrow going into it. Then our last statement here is that these two triangles are congruent. We used the SAS conjecture. And so there were three separate things that we needed to know that those two triangles were congruent. And they are these congruent angles, these congruent sides, and these congruent sides. So in this case, our three things are all going to point into the fact that these triangles are congruent. And that's going to be how our flowchart proof is laid out. It lets you kind of see a cause and effect again. So what told us that these two triangles are congruent? Well, it's these three pieces of information. What told us that these two pieces were congruent? Well, the fact that they were bisecting each other. So it lets you kind of follow the logic. Another really nice thing about flowchart proofs is it lets you see the structure of the proof a lot better. So we talked about how you always have to have these three things, your three different pieces before you can prove that the triangles are congruent. Now you get to see that a little bit more clearly. It actually gives you a visual way to see that. These three things directly have to point into this. Every time you claim triangles congruent, you better have three arrows going into it. And if it's SAS, it better be two pairs of sides and a pair of angles, just so that you kind of start to see how those are all working out. So we're going to do one more here. This one I'll have you just kind of write down directly as a flowchart proof. So this would be a good time to pause this video. Try it. This is only going to get better if you try it out, because then you can kind of compare to what we talk about and see. So pause the video. Okay, so you tried it out already. Let's go ahead and start to see what you think. So a good thing to always start with is the givens, right? So we've got this given and we've got this given. And so we'll go ahead and say those. We're going to list those as separate things. EC is congruent to AC. We'll put a box around it, and that is given. We've got ER is congruent to AR. Put a box around that. That is given. That's two things. I'm going to go ahead and put marks on them. And now we need at least a third thing, right? So you're looking at that picture, you're seeing, are there any conjectures that help us out there? Not really any conjectures, but what there are is this shared side in the middle. So that can be one of our reasons. RC has to be congruent to RC. Put a box around that. And I'm just always going to put same segment for that one. I think I mentioned in class that officially that is the reflexive property. Okay, so at this point now we've got our three pairs of things. These sides with the 1 mark, these sides with the 2 mark, and our shared side with the 3 mark. So at that point, we know that we can take those three things and together, when we combine those three things together, what that can tell us is that the triangles are congruent. So we've got triangle REC and triangle RAC. And that is our side-side-side conjecture. So you always, again, have to see those three arrows pointing into the fact that your two triangles are congruent, because your two triangles are congruent because of this SSS. And it's important that those three arrows come from a pair of sides, a pair of sides, and a pair of sides. Now, our last one here, the question asked us, is angle A congruent to angle E? And if these triangles are congruent, then yes, they are congruent. So we can go from there, we can say, yes, angle A is congruent to angle E. And because of our CPCTC. After we've proven that the triangles are congruent, then we can say that the corresponding parts are congruent. So the homework for tonight is just 4 questions. Okay, it's 4 flowchart proofs, and they're fill-in-the-blank flowchart proofs. So they're in your book, and I also have these right here. So I will actually leave this as a PDF for you to have access to. So if you need to see those and you don't happen to have your book or the online copy handy, you can have these too. But what you're doing is you're filling in all the blanks. And it says here in the directions, you have to copy the whole proof into your assignment and fill in the missing information. Because I want you to start seeing these structures and these patterns. And that doesn't happen if you just fill in the blanks. Okay, so those 4 proofs right there. And talk to you later.